So hey, my name's Michael. I'm here to talk about metadata, user data, and vendor data, which are all features of OpenStack compute. So if you're here for a Neutron talk, you're not in the right room. I concede we don't have compute or Nova or whatever in the title, so I thought I'd start with a disclaimer. But yeah, we're going to talk about the metadata facilities of Nova. Now to start off with, who on earth am I? So my name's Michael. I work for a company called Aptera, that I'm sure you've heard of by now. We hand out t-shirts, apparently. Apart from that, I'm an OpenStack compute developer. I've been working on Nova for about 6 years now. Over that time, I've done a bunch of stuff. I've worked on this metadata code. I've worked on security model stuff, like the proof set work we're doing at the moment. I was the compute PTL for a couple of releases. And I was a core reviewer until I stopped being a core reviewer, if that makes sense. These days, I spend most of my working day helping customers work out how to deploy OpenStack, which is what I do at Aptera. But I still hack on Nova because it's interesting to me. So what is metadata? If you asked a librarian, they'd tell you that metadata is data about data. Specifically, in the OpenStack case, it's the data about your instance. So it's IP addresses, SSH keys, the host name, that sort of thing. So you can think of it as the data that your instance needs to start up. So it's how Nova communicates, hey, it would be super cool if these SSH keys or this root password was used so that the user could log in. IP addresses are a special case because they're normally collected from DHCP, but there is other network information that you might need to come up in a meaningful state. So metadata in Nova is also a little bit weird, to be completely honest. It's weird because it's different from how we do lots of other things, and it trips up a lot of Nova developers as well as users. It's versioned in a different way, for example. And the reason it's different is because it's really, really old. So this was the commit where metadata was added in inverted commas. I say inverted commas because this is the first public commit for Nova. So back when NASA said, hey, we think we've got a thing and people might want to use it. Let's show our thing to people. Metadata was already there. So it kind of predates the mists of time. I can't even tell you who wrote the original implementation because it's not visible to us. Back then, Nova had 5,000 lines of code. So life was simple, things were small, and a big chunk of that code was devoted to this metadata stuff. So even then, they thought this early configuration problem was interesting enough to have devoted a bunch of effort to. Now, there are two ways these days that you can get to metadata. The most commonly deployed one is a thing called config drive. Config drive takes all of the metadata that Nova has and it renders it into a disk that is mounted, connected to your instance as it boots. Generally, that file system is very small. Depending on your hypervisor, it's either sized to the exact size of the data or is 64 megabytes. And we normally use a read-only file system because config drive can't change the data once it's created that disk, because operating systems don't expect you to change the data on the disks underneath them. But the file system we use varies depending on your hypervisor. It's sometimes ISO 9660, which is the CD-ROM file system, and it's sometimes VFAT. For instance, the libvirt driver uses VFAT because of bugs in libvirt that existed a couple of years ago and are long gone now, but now everyone expects it to be VFAT. So we're kind of where we are. There's also Metadata Server, which was the thing that was in that first release, and it presents exactly the same data over an HTTP connection at a well-known IP address. The biggest difference here is that the Metadata Server is a live view of the data. It can change. So for instance, if you change the SSH key pair associated with the root account, then that is visible in Metadata Server, even though it's not visible in config drive. But either way, you mostly get the same data. So I wanted to show you config drive, but how do you demo a directory of files? My answer is that you do a directory listing and you hand it to your graphic designer at work and say, make me look not stupid, and this is where you land. So this is just a recursive directory listing, only showing directories, not files. And you can see that this config drive, which is an instance I booted a couple of weeks ago, has an OpenStack directory and an Ec2 directory. The OpenStack directory is our homegrown metadata format. And you can see underneath that we have these date-labeled directories. And so we've changed the version of the OpenStack metadata a lot more frequently than the Ec2 version. And then the Ec2 version is those last 3 lines. And you can see we haven't actually updated the Ec2 metadata since about 2009, which is actually a really long time ago when you think about it. So there's a couple of things worth noting there. The metadata is versioned with these subdirectories that are the date that we added that metadata version. There's a latest directory, which is just a flat-out copy of the most recent one of those. And we don't really change the Ec2 metadata. So if you're sitting around waiting for us to add support for something that Ec2 has done to their metadata, no one's working on that thing anymore, especially since we moved the Ec2 compatibility APIs out of Nova. So if you're silently waiting for us to add something, it might be time to come talk to the Nova devs. That said, that hasn't happened in like 3 or 4 years, so it's probably not necessary. The directories are also, sorry, not directories. The metadata changes are also generally backwards compatible. We add things, we don't tend to remove things. So if you were building an instance image, it's pretty safe to use the latest directory. I don't know, if you had a specific requirement, like you thought that that image needed to last 4 or 5 years in production for some reason, then maybe you'd pick the most recent date at the time that you built the image. And I think I've said all of that. Yeah, changes are generally additive, so it's fairly safe, and we haven't done a great job of keeping up with Ec2. Now, if you looked inside one of those OpenStack metadata directories, you'd see 4 files, depending on the release of OpenStack, I suppose. The first one, metadata.json, is those examples I used earlier. So the host name, the SSH key, the root password for the admin account, that sort of thing. The network data.json is information about the network interfaces on the machine and how they're wired up. So the MAC address of the interface and the virtual network ID that that interface is on. So for instance, if you had a router instance, you'd need to know which one's the innie and which one's the outie, and that information is there. You'd still have to determine which network is which, and you'd use user data probably for that, maybe vendor data, but we'll talk about those in a minute. And then pretend the vendor data ones aren't there, because we'll talk about those in a moment. Now, just in case anyone's curious, that's a complete dump of a real config drive on my website. The QR code is just the URL for ease of taking photos or whatever, including the admin password for my instance. You're very welcome, although you probably can't get to the rack in my garage. I'm going to pause until all the cameras go down. You done? Cool. So this is an example of what's in that metadata.json file, and I just wanted to share a quick hot tip. This is what it actually looks like. It's not pretty printed in any way. Python ships with a little tool that will pretty print JSON so that humans can read it without wanting to hurt me. So that might be useful. Basically, you can take any JSON. It doesn't have to be our metadata. Pipe it through python-n json.tool, and it will indent it nicely and sort things alphabetically and all of that kind of stuff. So that might be useful to you. Now, the metadata server is very, very similar. It sits at this IP address, which I'm not going to recite because that would be boring. And it's, Nova and Neutron negotiate with each other to make the packets from your instance go to the metadata server. So there is a rewrite thing that happens under the hood that you probably don't need to think too much about. And it's effectively magic. And then you just make HTTP requests to this very simple server. Now, I said it's the same data. There is one exception. If you go to the root URL, what you get is the Ec2 metadata. So there's a couple of things to note there. There is this slight difference in the pathing, but also there's a whole bunch of extra Ec2 metadata versions available from the metadata server. And that's because we have space constraints in config drive. Now, the reason we do this weird thing where the root directory is different is because if you take an instance straight from Amazon and boot it on OpenStack, it doesn't know that it's running on OpenStack, obviously, and this is the location Ec2 puts that data at. So this is effectively an Amazon compatibility thing. But all up, there's 3 URLs that you probably care about. There's that root directory we just talked about, there's the OpenStack URL, and there's the Ec2 URL, which are exactly the same as they are on config drive. I like it when people take photos. It means they're awake. And here's just another quick example of the pretty printing thing. So it works with curl output as well, for instance. So this is exactly the same file in the same instance, fetched over HTTP, and ta-da, you get the same result. Now, if you're a deployer, there's a few things you should know about Metadata Server, or you're going to have a sad face. Now, the first thing you should know is the metadata server is part of Nova, so it's part of your control plane. And some networks have a policy where instances can't talk to control plane services. So, what you're doing here effectively is you're sending a packet from an instance to a thing that's running on a box that's much more trusted than where your instance is. And so that can be an issue for some networks. So for example, Rackspace Public Cloud doesn't use Metadata Server because they just have this policy that says instances don't get to talk to our control plane stuff. That might be an issue for you. We've never encountered anyone who's actually been owned running Metadata Server, but I'm not going to promise that it will never happen because then it'll immediately happen. But it's just something to think about. Does this apply to you? Is it a concern? So lots of people just deploy config drive, which is ironic because when we wrote config drive, we said, we know this is weird. Don't worry, we'll delete it in a couple of releases. And now we're really stuck with it, so that's gone quite well. The other thing is that the way Metadata Server tells what instance it should give data about is it looks at the requesting IP. So if you have a proxy in between the instance and the Metadata Server, which you might want to do for reasons of scale or load or whatever, what happens is the proxy adds a header to the HTTP request that says X forwarded for the IP address that made the request. And this is like a standard thing that proxies do, and the Metadata Server will use that header if it's present to decide what instance to provide data with. Now, I'm sure most of you can see the security vulnerability there. If I don't have a proxy, then my instance can just add an X forwarded for header to the request, and ta-da, I know your root password, SSH keys and all of that kind of stuff, which is probably bad. You have a couple of options there. You can disable honoring X forwarded for on the Metadata Server if you're not running proxies, or if you do have a genuine need for proxies, and some people do, you can configure your network so that only those proxies can talk to Metadata Server, and you can have those proxies not honor X forwarded forwards that are handed to them. So I've met deployers, for instance, where for reasons they can't fully explain, their users query Metadata Server once per second. And so, they really, really want to run proxies because otherwise they have a load issue. I've said all of that. Now, all of the security concerns are covered by an OpenStack security note, which is at the next QR code. So that's probably worth reading if you're deploying Metadata Server in production. And there's a camera, so I'll wait a second. Cool. Now, config drive and Metadata Server support 3 types of metadata, which is kind of the meat of this talk. So the 3 types are metadata, which is data that Nova wants to tell your instance. So it's IP address, the SSH keys that you provided in a key pair, passwords, that sort of thing. So really simple configuration information in order to be able to bring the instance up. Now, you should note, if you're talking to a Nova developer, that Nova has 2 completely separate concepts of metadata. So internally in the code, there's a thing called system metadata, which is things that Nova wants to know about the instance. And there's instance metadata, which is the stuff we're talking about here. In general, the user-facing stuff is just called metadata. But if you're talking to a developer, like for example, you're reporting a bug, and they're asking really confusing questions, they may be thinking about the other type of metadata. But apart from that sort of scenario, you can completely ignore system metadata. The next type of metadata is user data. User data is data that is provided by the user that started the instance. So this, for instance, could be a shell script, or it could be a configuration file. And it's how Heat, for example, configures instances when it boots them. It generates these little shell scripts and says, go do that thing for me once the OS has come up. This is, for instance, how you would configure Puppet or Chef or Juju or Ansible or whatever the cool kids are using these days for configuration management. You wouldn't use user data to replace those things. You would use them to configure those things. So you could have a shell script that writes the configuration files that you need for Puppet, like hey man, go talk to this one over here or whatever, installs the Puppet packages, and then let Puppet run from there. And Red Hat has a really good user guide on this stuff at this surprisingly short and convenient URL, which is what prompted me to do QR codes in this talk. I'll wait for my former co-workers to stop taking photos. Thanks, guys. But I'll give you a quick example as well. So here, I've decided what I want to do is automate starting a dev stack on an instance. So the top bit is me just writing a file. and that file is a shell script. It does an OS update. It installs, it goes and git clones DevStack. It writes some configuration stuff you have to do, otherwise DevStack's going to prompt. And then it runs stack.sh. And then the way I'd start an instance to use that is -- user data, the file that has my magical goo. And off it will go. Now, there's an interesting point here. So if you run this command and then do a Nova list, the point at which Nova says the instance is started is the point at which Nova has finished creating the virtual machine on the hypervisor, plugging all the networks, and has started the kernel booting. Now, normally people don't notice because kernels boot pretty quickly, especially on virtual machines. And so it's all puppies and kittens. This script, depending on your network, will take half an hour to run. So Nova list says the machine is done. And maybe this script, is creating user entries and stuff so you can log in or doing whatever it is that makes this machine useful. And if that thing takes a really long time, Nova list is not a useful way of telling if the instance is up and usable yet. Nova doesn't really solve that problem for you, so you'd have to work out how to do that yourself. But for instance, if this was a web server and it was behind some sort of load balancer, you'd probably want some sort of health checking that doesn't send traffic to the instance until the instance declares itself healthy on start. And then there's the bit that prompted this talk, which is a thing called vendor data. Now, I say here that vendor data is the new kid on the block, and that's because I'm lying. Vendor data has actually been around for a while. Now, originally, it was this plug point where you could provide a Python module that ran inside Nova that would do stuff for you. And it turns out the Nova devs really, really hated that. They generally hate other people's code running in their process space because it causes reliability issues, and it means if we refactor the code, your thing breaks, and then you send us hate mail and all of that kind of stuff. So instead, we replaced that with this external web service thing that is the new vendor data, and which is a lot nicer, to be completely honest. And this is how deployers would tell an instance stuff about their network. So, hey, my NTP servers are over here, or, your Puppet configuration should look a bit like this because I know Puppet, because I, own the enterprise network or whatever. But the most common example is cryptographic information so your instance can register. So for instance, if it was registering with Active Directory or free IPA or something like that, what you would want to do is hand through some cryptographic goo and then have something inside the instance that knows how to use that goo to go off and talk to Active Directory to finish the registration process. Excuse me. So specifically, the reason this happens is you don't want to trust Nova to administer Active Directory. That's probably a mistake. And you don't want to trust the user to administer an Active Directory. That's definitely a mistake. But you do, as a deployer, trust yourself, hopefully. So what you do is you would go and write this little thing that runs as a separate user that has permissions to talk to Active Directory and could do the initial steps of adding an instance. That thing creates whatever cryptographic nonce is needed to go and auth post-boot in Active Directory, hands that through to the instance, and then there's an unprivileged thing on the instance that really all it can say is, I have this magic number and I work now. And today you're registered in Active Directory. And that's pretty much the problem we're trying to solve with vendor data. Now, there are two forms of vendor data at the moment. We might add more in the future, but we haven't thought of an excuse yet. There's static JSON. So this is my NTP servers are here, or my Puppet server is there, or whatever. Things that pretty much never change. And it's just a JSON file on disk, and it's just added to the vendor data files, job done. So it's super simple. And then there's dynamic JSON, which is a module that knows how to go and talk to a web server, gather data for you, and return it to the instance. And that's where Active Directory and free IPA and things like that would be done. Now, to configure dynamic JSON, you need to add it to the vendor data provider's configuration entry in the API section of the Nova config. And then you need to add a target in the amazingly tersely named vendor data dynamic targets entry in the same section of the config file. So the example below here is an entry called testing that is running at that URL, including a port. And what happens when the instance boots, Nova will make an HTTP request to that endpoint and say, hey man, give me some vendor data. And it passes in HTTP headers a bunch of interesting information about the instance, like the user that started it and its UUID when it starts, and all of that kind of stuff, the tenant, whatever things we thought you might need in order to make a good decision about registering an instance or whatever. And then you get a chance to return JSON to us that we pass through to the instance. And then, so that data gets passed through in the vendordata2.json file, which is named like this because we changed the format when we rewrote vendordata. And so my testing service returns 3 values, 1, 2, and 3, because we're exciting. Now, your external HTTP server also gets to use Keystone to authenticate the requests from Nova, because maybe you don't want random people going and doing the cryptographic stuff inside Active Directory. And that's just done with standard Keystone middleware. It's not magic or anything. It's just WSGI paste. And Nova, you can configure Nova to use a specific Keystone user when it authenticates with your external service. So if we do this, what we end up with is a config drive that has a vendordata2.json file that contains whatever these external services return. And you can have more than one external service, which is why it's namespaced like this. So my little example, for instance, returns useful Carrie Fisher quotes. And so, my testing service says, Carrie says, I really love the internet, etc. And there's a fully worked example of how to do this on my website at yet another QR code. That includes a complete HTTP server that does Keystone auth, instructions for how to set it up, everything you'd need end-to-end to run this, and it returns Carrie Fisher quotes. So that could be a message of the day or something really important on your service. And that's been documented for quite a while, probably nearly a year now, I'd have to look. And nobody's come to me and said that it's bonkers and doesn't work. So either no one's using it, or I'm a genius. It's really hard to tell. OK, so we've passed all this data into the instance, and that's cool. What happens then? So it doesn't have to be Cloud Init that processes this data, but as best as I can tell, it's always Cloud Init that processes this data. So Cloud Init is this little Python program that runs on a whole bunch of different clouds, like it supports Amazon, for example. In fact, even supports non-cloud things like KVM, I'm told. And what it does is it knows how to go and find a config drive or a metadata server and then use the data to do useful config things. So it's the thing that knows, oh, you've passed user data, and it starts with a shebang, so it's a script, and I'll execute it. Normally, Cloud Init is configured to only run on first boot, which may or may not be useful. Like, for example, if you've changed the key pairs for the root SSH account, maybe you want to be able to reboot the instance and have Cloud Init rerun to rewrite the key pairs. But by default, it runs on the first boot and then goes away. And it's probably running on your instances now if you've downloaded them from a distro vendor. And if you've never noticed, it's just because it's not very obtrusive. So that brings me to kind of the summary point. For better or for worse, Nova metadata has been largely ignored for the history of OpenStack. For whatever reason, it's just not a super exciting space, which means it tends to stay still until something bad happens. So Vendordata 2, for instance, happened because the Nova developers decided to remove the first implementation of Vendordata, and there was an operator mutiny because people were actually using that thing and we didn't realize. And so we went and fixed it. That's why I say if you're particularly waiting for something to appear in metadata, you probably need to come and talk to us, because there's no developer who is just full-time on metadata or anything. It tends to get handled when people come and make a request and the request isn't crazy and off we go. But that's so rare that there is no kind of subject matter expert on metadata. I'm probably as good as it gets, and I haven't touched it in a year either. Yeah, so normally people come along because they have a specific need and they'll do that thing and then they go away again, which I think is, I guess, probably good is the other way to look at it, because it's extremely stable. We just don't change it. It just works. You're welcome. But I am interested in having a discussion about if that's OK or if there's glaring omissions. I'm especially interested in if people are actually using Vendordata 2, or if there are gaps there that we should be fixing, because that code's still relatively fresh. And so if there's changes we need to make, then we probably should. The original spec for Vendordata 2 also promised some stuff that we never actually did. Like we said, oh, and we'll honor HTTP cache headers. And then we didn't. We just didn't write that code. We didn't get around to it before release day. But no one's ever come and complained about it, so maybe it doesn't matter. So that would be an interesting conversation to have. And yeah, vendor data is, like I said, an example that was added just because operators requested it. So I'm happy to talk about that stuff and take questions now. I'm also happy enough just to have people come and chat to me. I'll probably lurk around the Aptera booth for a bit and hand out T-shirts because I don't have adult supervision. But I'm happy to take questions now as well. Yes, Dave?
So 2 points that you didn't mention. First one, is CloudNet, you're not the CloudNet guy, I know, but does CloudNet always read Metadata Server first, and then if that fails, then it reads config drive?
Okay, so the question is, what order does CloudNet read Metadata Server and config drive? I'm actually not sure, to be honest. James has a theory. James, come on.
So it depends on the version of CloudNet. So newer versions take hints from things like the machine being presented via QUKVM, and then I think they'll look for config drive first, and then go to the metadata service, because it's a faster operation to check the block device than it is to do the handling.
Okay, to summarize the answer, it's changed over time and is magic. But normally config drive, because yeah, you'd experience an HTTP timeout if you were trying to talk to a metadata server that wasn't there, and that would probably annoy you because it's a couple of minutes.
And the follow-up question was just, config drive also works with IPv6 because there's no 169.254, 169.254 and IPv6.
Yep, okay, and the other thing is config drive works with IPv6 because there's no IPv6 equivalent of the 0conf IP address that we use for the metadata server. That's probably an omission we should fix. That should probably be a bug report. I don't know if there's heaps of people who actually use IPv6 with Nova, to be completely honest. I know that we've added it to the metadata, like the data in the files, but like nobody's come up to us and said metadata server doesn't work, so we've never noticed. Like we don't use IPv6 in the gate. Yeah, there's probably more of those users in the future, and IPv6 is bigger in parts of Asia than it is in North America, for example. So it might be about the kind of users that we currently have and things like that. Sorry?
It might be specific to the industry as well. So telcos are more likely to use IPv6.
Yeah, it might also be industry specific. That's true. Yeah, we would fix that bug report if someone made it, I think. It would be interesting to see what Amazon did, because we just totally stole how that works off those guys. And presumably they have an IPv6 story. And yeah, I'd have to go and look at it. It's interesting, right? Because back in the day, we used to read the Amazon Ec2 metadata specs, and we would try to keep up. And then we stopped caring for whatever reason, because it just worked. And so we haven't since, 2009 or something really embarrassing. Yeah. Correct. Yeah, so the passwords, etc., are in plain text. You can, in fact, config drive, sorry, what am I saying? CloudInit unmounts the config drive when it's done. But there is nothing stopping a user from requesting metadata server and getting the admin password. No, there is. Aha, you're saved. One thing I meant to mention earlier, but I forgot, is so config drive is this point-in-time snapshot of the data, because we can't change the data while the OS is running. But what about reboots and rebuilds, right? The OS isn't running. We could change the data. Except we can't, because we don't have all of the data anymore. So the root password is thrown away once it's written to the config drive. So if we did a rebuild or whatever later, that data doesn't exist, so you wouldn't get it in the new config drive. So we've never supported rebuilding config drives. That's actually a thing that people were starting to talk about in Denver, because if you, Fred is your admin, and Fred rage quits and he takes the SSH keys for the root account with him, you kind of want to be able to push SSH keys out to instances without having to throw them all away. And you could do that with a rebuild if we rebuilt, like an instance rebuild, if we rebuilt the config drive at the same time, and if CloudInit ran again. But none of that stuff happens. So we're starting to talk about it. That saves you from users being able to get to the admin password on the metadata server as well, because when they make that request, that field is blank. So they'll get the SSH public key of the root account, but they won't get the root sudo password because it's gone. And so, I think we're going to accidentally save from that scenario. They will get other stuff, though, like the complete network configuration for the machine and stuff like that maybe they can't see, if they're in a container, for example. No, there's no way to encrypt Metadata Server.
But with your user data or vendor data, you can put any encrypted information in you want.
So you could put like blobs of encrypted goo in with user data or vendor data, but then you'd have to have the key transmitted somehow. There's a bunch of issues around here. You probably actually just use metadata enough to bring up the instance in order to bring up something like HashiCorp Vault or whatever that was actually your cryptographic tokens. Metadata is not intended to be a replacement for sensible systems for doing that kind of stuff. It's just an early boot helper process, if that makes sense. Yes?
Does Cloud Init support the OpenStack format in addition to the EC2 format?
Yes, so Cloud Init supports the OpenStack format and the EC2 format. In fact, the reason that config drive exists is because the Cloud Init author came to me, because we both worked at Canonical at the time, and said, dude, could you do this thing? And so they kind of requested it of us, which is why we did it.
I think with the default Ubuntu image, for example, Cloud Init will connect to the EC2 version using the HTTP endpoint.
Mm-hmm.
So why is it not using maybe just it's not using the OpenStack format?
No. So what we're saying is that Cloud Init will prefer, we theorize that Cloud Init will prefer the config drive version because it's faster to access. If that's not available, it will go to the Metadata Server and it will probe to see if there's an OpenStack version available. It also has magic to be able to try and work out what cloud it's running on. So it goes through a probing process where it tries to find data in the usual places and then uses whichever one it thinks is best, if that makes sense. Anything else? Cool. Come see me at the booth if you have other questions, or send me hate mail or whatever. It's all good. And happy to talk to deployers who are using vendor data, especially if it doesn't work. That would be embarrassing at this point in my life. Cool. You have 6 minutes to get to a horse race. Go.